Hello and welcome to Kivy School. Today I'm going to show you a Kivy RecycleView tutorial. It will be a deep dive for beginners, and it will be RecycleView versus ScrollView, examples and analysis. Now this is going to be the GitHub repo. I will update this completely later, but just letting you know, if you want to see any of these examples, visit this GitHub repo and then you can just run them. Okay, so I did this and this. Okay, so what is a RecycleView? RecycleView is a widget that displays a selection of many widgets at once. And then now you're saying, okay, I have ScrollView. Why should I use RecycleView? And I'll show you why. First, I'll tell you why. RecycleView is very performant. It's not laggy. It lets your app handle a lot of data without having to draw the data, aka lag out your app. So there are a couple of use cases off the top of my head. One is going to be handling inventory. Let's say you're handling a lot of materials and stock in your little warehouse. Okay, you're not going to have like one thing. You're not going to have like two things. You're going to have like hundreds, thousands of things. You need to handle a lot of data, and then if you have like 100,000 widgets in your Kivy app, it's going to lag. It will just straight up lag. So handling inventory is one use case. Another use case is handling a library of songs, right? Songs could be like, you can have like one song, you can have 10 songs, you can have 3,000 songs, right? That would be another use case for RecycleView. Another use case for RecycleView is handling complex widgets that are lagging out ScrollView. If your ScrollView is lagging out, check out RecycleView. If you check out RecycleView, that will be your solution. Now here's going to be a concrete example. You have workers that you need to pay, right? Signified by selection behavior. Okay, so let's go poetry shell to go into our virtual environment. And then, okay, let me reset this. I'm going to press Control J. Oh, okay. So like this, Control J, so like this. Okay, poetry shell, and here, poetry shell to enter our virtual environment. Now we'll type Python, and then I know it's workers. And then you can press Tab to autocomplete, like this. So it will autocomplete, and then you'll have your workers paid. So right now, look, they're all sad, I haven't paid them. So now I click like this. Oh, I paid worker with ID 2. Now they're happy. I will pay worker ID 10. Now they're happy. I'll pay ID 4. Now they're happy. Oh, but the check bounced on worker ID 4. Okay, now they're going to be sad. So you can see already that RecycleView is very good for handling this kind of thing. And then you can see right now that there's up to like 10 widgets. Okay, you can do the same with ScrollView. But right now I will show you why RecycleView will handle ScrollView a lot better. Because we'll say we'll have like 100 widgets, 1,000 widgets. So you'll see this very shortly. But this is just a very quick example of some of the things you could do with a RecycleView. Now another thing I have to note is this note right here. I'm using this trick, well not really a trick, but from Kivy core window import window. Window's always on top for most of the examples, just because if you press like this and then you see it, the window is not going to show. Why? Because it's not on top. You have to spend time to click on it to make it on top. And then you see if you click here, it will be hidden. But if you do on top, then you press up arrow and then re-enter the command, it will always be on top. It's just good for displaying, but don't use this for apps unless you're in dev mode. Okay, so I've done this. Okay, now we're in part 2. I'm going to show you why should you use RecycleView. So this is a basic example from Kivy org. So let's go Python, the basic. So you see right here, this is the basic example from Kivy org. I've taken it from this one, and I think it's this example right here. Because there's a second example here, it's got like a checkbox, which is not what I'm using. It's this one. So with this example, you see you have, how many widgets do you think I have, first of all? Right? I'll give you a little bit. How many widgets do you think? So here it's going to be 100 widgets. Why is it 99? Because you count at 0. You start at 0. So 0 to 99, 100 widgets, right? Now let's check out ScrollView, right? Python scv.py. Let's check out ScrollView. How many widgets is this? It's going to be 100 widgets as well. So okay, seems performant, right? Both ScrollView and RecycleView have 100 widgets. But now let's do a performance test. let's say I want 1,000 widgets. So we go right here, it's RV Basic, and then ScrollView. So here it's just making everything viewable in the window. So this is the data, 100 widgets. I'm gonna put 1,000 widgets, and then right here, 1,000 widgets. So Python, what is this? RV Basic. Okay, it's going to be 1,000 widgets. You already see this scroll bar is very small already. Let's see if we can go to 1,000. Very quickly, 200. Can you select these? You can't. Okay, let me exit because I have PDB here. Actually, let me remove PDB right now. Where is this? Okay, so we're going all the way. We will see the 1,000. So actually the last widget is going to be 999, not 1,000, because again, we started 0. So if you started 0, at the very end, you got a -1, because your first number is not 1, it's 0. Going all the way, pretty fast, pretty performant. All the way to 999 widgets. See right here? Oh, you can't select it. Okay. 999 widgets. Cool, right? Now let's go with ScrollView. So Python tv.py. Okay, it's taking a while. It's taking a while to load. Now let's go all the way to 999. And it doesn't even have to be like the number of widgets. For example, like if you have complex widgets, that's also going to lag you out. So because if you see this, these are all just buttons, right? So buttons, very simple widgets. But once you have complex widgets, then you should start thinking about implementing RecycleView. All the way up to here. Also we got 999, right? To 999. Okay, cool. It was a little bit laggy. Let's try. Okay, we tried 1,000. Now let's try 10,000 widgets. Enter. And 10,000. Save and save. Here we go. Python RV Basic. Okay. All the way to 10,000. Okay. Some lag. Then I'm not sure if I can. I know there's a way to like make this bar draggable. I didn't implement it. Okay, let's go. Keep clicking. So it's still very performant. You can still click like this, right? It's just past 999 just to show it is 10,000 widgets. See, 10,000 widgets. All right, now let's try Python. What are you? SCV. Enter. Okay, it's taken quite a while. Just I hope it doesn't crash. Right? So with RecycleView, it works. With this, oh, something happened. Oh, my virtual machine died. Okay, okay, so already lagging out. It's lagging so bad that my virtual machine cannot run it. So already at 10,000 widget, it's failed. Now, just because I'm curious, let's try 100,000 widgets. Let's see this. 100,000 widgets. Save and save. Python Basic. Okay, see, even at 100,000, it's still lagging out. But come on, it's 100,000 widgets, right? 100,000 widgets in the virtual machine. Pretty good, if I say so myself. Okay, now let's try Python SCV. Right? This, most likely it's gonna lag out. Most likely it's gonna lag out on my machine. We'll see. So I'm still waiting. 1,000, 2,000, 3,000, 4,000. But you get my point, right? If you have something ScrollView, if you have a ScrollView that's laggy, just use RecycleView. Check it out. Okay, let me talk while this is loading. So now that I've shown you why you should use RecycleView, I'm going to show you some examples of RecycleView, just so you can see different kind of things you can do. So hello, is it loaded? Okay, it's dead. Done. Okay. Oh, wait, maybe I crashed my machine. Okay, it's so laggy, it's not even responding to inputs. It can't even respond to Control-C. So there's going to be a couple examples. Now let's try RV Basic 2. So Python RV Basic. if you press tab here, it's going to use the original one, right? So I need to say RV basic 2. Now it will do the correct file name. So see this one. You have any notes? Okay. So this one is the second example from Kivy org. Where are you here? This one is the one with the checkbox, right? It's just saying, oh, you can have a view class state, and that you can have a stateful label. Basically, these labels are, they're changeable. It will have a state. So for example, the most important part is I've got a checkbox, right? And if I leave and I come back, oh, the checkbox is still checked, right? This checkbox is still checked. And the big part about implementing RecycleView is knowing how to manage and maintain the state, which I will show later. So this is, one more example what you can do with RecycleView. Go here. Now we'll try Elliot's example. Very specifically, this question on the Kivy Reddit was exactly why I made this video, because RecycleView is very good, but nobody uses it. And then the other thing is nobody has documentation. Rather, it's really hard to read Kivy org. So I'm making this video. So this example is here. It's going to be the 2 buttons. It's going to be the 2 buttons app from Elliot DG. Now let's run it. So Python Elliot DG. So what it does is you've got a RV list. It's got a left button. Oh wait, I've changed it a little bit. Where's PDB? I have a set tray somewhere. Oh, I don't. Okay. Never mind. Okay. Left button, right button, right? This is also a slightly complex widget. Why? Because right here it's going to be 2 buttons. Okay. Right here's 2 buttons. 1 second. Where? Oh, here it is. So 2 buttons is box layout right here. And then within each box layout, you have 2 buttons. So and then you can keep adding. And then these are clickable buttons, right? So it's a good example. It's very complicated. And then you can see the change, right? So, and then you see this is always on top, so you can have like information here. Good example. I really like it. Okay, so these are all the examples from Kivy org. These are the prerequisites. You need to have watched this video first, which is the previous video I've made. Basically, it's how to install Kivy and then run Kivy examples. These are all going to be in the... Let me just go there very quickly. Here? No. Okay, but they're going to be in the... Actually, I'm just going to copy this. Let's just install examples right now. Okay, it's installed. Now it's going to be under Share, Kivy examples, and there's a lot of examples. Right now it's going to be widgets, and then you're going to check for RecycleView, which is right here. So in your virtual environment, you go here under Share, Kivy examples, widgets, RecycleView, and these are the examples that I'm going to show you. I just copy and pasted it. Then you can run in code in place. I've done this, I've done this, I've done this, I've done this. Okay. Now let's do Python basic data.py. So what's my notes? It says populate, sort, and clear. See, it doesn't have the window on top, so I gotta click, but it's not a big deal. So what does this RecycleView do? Populate list, insert new item. All right, so A, B, C, D. Insert new item. Update first item. Like this. These are updates. Remove first item. So again, how to manipulate a list, right? Sort list. That's pretty cool. Clear list, right? So this is a basic basic data where you populate, sort, and clear. Okay. Let's try Python infinite scrolling.py. Okay, click here. So this is just an infinite scroll, right? You see hi here, and then you just, if you go down, it will just populate with more messages. Just populate. So pretty cool, right? And it has like the time and date stamp, right? Pretty neat. Okay, so that's another reason why you'd want to use a RecycleView. Let's do Python key view class. Here it's going to be very complex widgets right here, right? You still see, you still see the checkbox right here. Pretty cool, and all these text inputs. Alright, so this is a text input, and then if you scroll out and you scroll back, still preserves the info. Let's see. And then these are buttons. Oh, this is a drop down right here. Drop down or AAA. Let's see. DAB. Okay. Still remembers, right? So very good, complex widget. You know, something that you can look at. This one is excuse me, where are you? So it's KeyView class, right? And another important thing is that, where are you? Just want to highlight that the KeyView class is widget. Now why is that important? Because if you notice here, the heights of these widgets are different, especially this widget right here. And it's important because sometimes you have a problem where you want your RecycleView to show different heights because your widgets are sized differently. So you use KeyView class widget, not you see. Let's look at Elliot's example. I don't think the KeyView class will be defined, but it will say the view class will just be 2 buttons, right? Because you always have the 2 buttons class. It will most likely be a fixed size. If you want a different size, you just say widget, and it will display the widget for you. Okay, enter. There's a messenger, so Python messenger.py, and then just wait here, enter. So hello world. So this is another RecycleView example, and then they'll respond to you. This is a cool app. Oh, my enter key is exploded. Okay. Do you really think so? Now I'm not so sure. Sure. So this is another RecycleView. If you see up there, you can see the view. Pretty neat. And then this is a text input. Excuse me, this is a text input. Okay, pull to refresh. Python pull. So here, you pull down. So hello, run. You pull down like this. It will refresh. Then 10 to 20. Up there, pull down again. It will refresh. Pull down to refresh. So it just populates the list, and it's pretty neat. Neato. Scroll up and down. You see all these widgets. Then they can be as simple or as complex as you want. The end result is RecycleView is very efficient at displaying widgets, and especially like data like this, and handling complex widgets. All right. We've seen pull to refresh. Now let's try Python reanimate. So this one, what's the cool thing about this? Let's press the button. Ooh, fancy animation, right? The animation is outside the scope of this video, but we'll get to it at some point. See right here, wow, this is a really nice animation. Okay, next. Okay, so I have more online examples. Let's do Python course update. This one is another example here. It just has updated text input, so updated text input. Then you can see if you scroll up right here, it still hasn't forgotten the message. Okay. And then let's go to Python init RV-data. So this one, it just has pre-initialized data, because sometimes in the other examples, yeah, gotta press a button and then it adds the data. But here, the data is already initialized on app start, which is pretty cool. Sometimes you want this. And it just says update list. Okay, updated, updates list. And it just updates the first row, right? So this is how you would initialize the list, plus how to update it. Okay, this is another one. It's not a complete example, but if you do Python, basically, your app is not always going to be just a RecycleView, right? You want to have Screen Manager and go through different screens. So here it says go to settings. I hope it still works. Let's see. Okay, my settings button. Okay, back to menu. Don't quit, because if it quits, I think it will just quit, right? Okay, we go to settings. So it has several screens, right? Now this is the RecycleView, and then you'll see here's the initial RecycleView, and then this is how you could implement just, you know, an idea that your app should not always be just a RecycleView. You should always combine all the components together. So this is how you would have a RecycleView and then use Screen Manager at the same time. Okay, let me skip these. All right, now this is my reference. What is the requirements for RecycleView? Okay, there are 4 components to RecycleView: RecycleView, RecycleLayout, View Class, and Data. RecycleView is the base widget. Inside of RecycleView is the RecycleLayout. It determines the layout of Recycle Children widgets. The truth is that Recycle Children widgets don't exist as a widget you create, but as a dictionary. These dictionaries are stored in RecycleView.data, a list. The dictionaries contain the values for the attributes of the widgets. The widget type is set in RecycleView under View Class Attribute. So you need to create a custom. Okay, I think that's just solving his problem. And then there are more examples in this link, right? Which is what I've shown already. So what do you need? A RecycleView, RecycleLayout, View Class, and Data. So let's go line by line on RV Basic and Elliot's example. So in RV Basic, which is the example from Kivy org, let's go line by line. So this is just generic imports where you're going to import app, builder. Builder just means you load the string instead of having a separate KB file. It's very nice to keep things compact. What is next? RecycleView, you need this. RecycleDataViewBehavior, you need this. It's just how to make a RecycleView. You need to import labels if you want to use them. Boolean properties, because this one is the where are you? RV Basic. This one is the clickable one. Oh, I think it still has 100,000 widgets. Let's change this. Let's go back to 100. Actually, I should also change ScrollView so I don't blow up someone's computer. Okay. So like this, it's 100 widgets. They use the Boolean attribute just to, if you know it's selected or not, right? Okay, what's next? Recycle box layout, that's for RecycleView. Focus behavior, just so you know if you've focused in on it. Layout selection behavior, again, that's from RecycleView. So builder load string, just to load the string instead of having a KV file. So it's a selectable label. Draw background to indicate selection. Canvas before. Okay, so this is just a canvas instruction. It will instruct it to color it like this if you're selected, or else like this, which is nothing, 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 and then 1 alpha. And then rectangle, self-pause, so we'll just color the rectangle. And then this is the RecycleView. The view class is a selectable label. This is it. Selectable recycle box layout, default size hint. These are all, you can see this in Kivy org. Then selectable recycle box layout, that's defined here. Otherwise, Kivy will complain, oh, it's not defined. Because if you use something here in KV, you gotta define it here in the Python. As a rule, you don't always have to do it. Add selection and focus behavior to the view. So selection is here from layout selection, and then focus behavior is here. And then this is the selectable label, which is a recycled data view behavior, and the labels inherits from both. To add selection support to the label. The index is none. Selected is a Boolean property, which initialized as false. Select the bool is a Boolean property, initialized as true. Now this refresh view attributes, it's got it's 3 args and then one, self. So it's 4 arguments. Catch and handle the view changes. You got self index equals index, return super. So this one is important just because they're calling the label, how to explain this? They're calling the label refresh view attribute. So they're calling the method of the superclass. So if you press F12 on VS Code, you go right here, and then what was I looking for? You do Alt left key, I think. Here, let's do this. See if I can look at it. Oh yeah, it's just catching and handling the view changes. 1 second. I think it's from label. So if you press F12 in label, then Control F, find refresh view. Nope. So then try here, RecycleView data behavior. Right here, it's just calling this, the superclass from what you inherit from. It's called by RecycleView adapter when the view is initially populated with the values of the data dictionary Any pause or size info should be removed. In any case, this just refreshes the view. So in the end, the super is just calling the parent classes, and then it's calling this method. On touchdown, so add selection on touchdown, super, right? All this means is that you're calling the touchdown method. So again, we look at the parents. Here, let's say, does RecycleView have a touchdown behavior? No, or touchdown method? Nope. So we go here, label. Does label have a touchdown method? Yes. So you're gonna call this method instead of, redefining everything. So it calls the touchdown of the label, so you preserve the label behavior. And then it says self collide point. So this one just says if your mouse touch and you're selectable, then you try the select with touch. And then apply selection. Respond to the selection of items in the view. So self-selected is selected. If you are selected, it will change. And then if not, you will go like this. Now this is the recycle view. What do you really need from the recycle view? Just self.data. So in the initialize, it will initialize the recycle view parent. So if you press F12, you will see there's an init here. It will just call this just to preserve the recycle view behavior. Because otherwise, if you don't call this, it will not run as a recycle view. It will just be init, do nothing. It will just be a class, a recycle view class with self.data, and it will not be properly initialized. That's why you need these supers. Then this is your test app, and then build self, return RV. This is just because you need to return a widget, which is this recycle view, and it will only show recycle view. If name equals main, this is just it's like a guard. It means that if you are calling RV basic.py, it will run. But if this is like a module, it will not call it because it will be loaded, it will be imported, and it will not be main. But because RV basic is you're calling RV basic, it will be main. But if you're importing it, it will not be main. And then from Kivy core window, import window, set it to top, that's okay, then run. So there's that. I've covered RV basic and then Elliot's example right here. So let's go over Elliot's example, right? A lot simpler, right? But I'm not sure if it has selection. I think the selection is from the selection behavior is from the button. Oh, it's not. There's no selection behavior. So it's a bit simpler. So Kivy app, import app. Kivy lang, import builder. You need this to, again, not reference Kivy file. Import recycle view, import box layout, and string properties. Okay. KV is this is the KV string. This is me. I made this change just to show later using Python debugging tools about inspecting, the app. Don't worry about this. This is the two buttons class declaration. This class is used as the view class in the recycle view. This means this widget will be instanced to view one element of data from the data list. The recycle view data list is a list of dictionaries. The keys in the dictionary specify the attributes of the widget. So here's a button, and then the text is root._left text. On release, this button is pressed. Don't worry about this. This is me. There's another button. So this class of two buttons has two buttons, right? There's a left text and a right text. And on release, it will just say, okay, this button was pressed. Now box layout, the orientation is vertical. This is the button. Add a widget to RV list, and on release, run rv.add. And rv.add is here. Right? All it does is extend the data list. What else? This is the recycle view, gives the ID. The view class is two buttons, which is here. And then if you notice, there's left text and right text, which is actually going to be defined here. What else? Where are you? The data is self.data list. So again, the view class is two buttons defined above. The data is a list of dictionaries defined below in the RV class. Scroll type bars, content, bar with 10, recycle box layout. This layout is used to hold the recycle widgets. Default size is none, DP48. This sets the height of the box layout that holds the two buttons instance. Default size hint is 1, none. Default size hint is Y, none. Okay, so this is just sizing, and then orientation vertical. And again here, when you define a new widget, you have to define it in KV as a class, and then again in Python as a class, just to specify it as a rule. There's ways to cheat it. So this class of 2 buttons inherits from box layout. So it's a box layout, and then it has 2 string properties, left text and right text. Who else is new? Okay, RV is new, right? Because that's not really a widget. Let's see. So here RV is a recycle view, and then this is a list property. A list property is used to hold the data for the recycle view. See the KV code, right? So we'll see the KV code right here. This is the data, right? So again, RV data list, RV data list. And then again, you got it init, super init, just so that you have the recycle view initialized correctly. And then in the initialize, you set the RV data list. And then this is a list. If you look, let's break this apart. It's a list of dictionaries. So it's just list comprehension. It says that for I in range of 2, you will add this dictionary. So what this will look like is a list like here. So range of 2 is 0, 1, and 2. So at 0, you go like this. I is 0. This is just it's going to be an F string. So actually it looks like this. Like this. 1 looks like this. Looks like this. So RV data will look like this. And I think need commas. So this is a list of dictionaries. And then these dictionaries will define these string properties, which will be inherited, not inherited, but it will be referenced through button text, right? So if we comment this, okay, so comment this out and come here. Let's fix this. Okay, let's do Python Elliot DG. So 0, oh, sorry. Range of 2, it doesn't do the end, so that's my mistake. So 0 and then 1. And then you have it correct. So this, let me see, what's next? Okay, this list comprehension is used to create the data list for the simple example. The data creator looks like this. Again, right here. Notice the keys in the dictionary correspond to the Kivy properties in the 2 buttons class. The data needs to be in this kind of list of dictionary formats. The recycle view instances the widgets and populates them with data from this list. Oh yeah, I'm supposed to remove the F because it's an F string. So left text, left 0, right text, right 0, comma. Okay. And then this is the add definition. It'll just extend the data list, and then this is how they extend it. Then this is the to app, builder load string, Kivy core window, Windows always on top, then you just run. So I've gone line by line. Talked about builder load string. And this is the reference, which I think I read already. Okay, next. Okay, let's actually go like this. So you're looking for an RV recycle view, right? Recycle view, you need the class right here. Where are you? Right here. Means use brackets, right? Okay, you don't really need to use brackets here. But there's just a quick explanation of KV. RV is not equal to RV. Right here, they use the widget. But then if you say RV like this is going to be a class definition, and then you will, say whatever you want. But for right now, because there's nothing special, they just use RV like this, and then they have a class definition here. And then TLDR, read, again, you gotta read more, read the rules context, right? But basically, the root rule is declared, okay, like this, class rules. So this is a class, and this is the actual use of the widget. So there's that. There's a layout, which is defined here. Recycle layout. Let's look for the recycle layout here, which is layout. 1 second. Recycle box layout right here. So they've defined this, our recycle view, then they've defined the layout, and then what else are you looking for? So there, you just need this. Let's see what's next. Now you need an actual view class. This is defined as view class or key view class. Where are you? Here. Now, if you notice, this is going to be the name of the widget. Okay, view class. View class is done. Then this is the data attribute, right? Now, this is data like this. You can usually, I've seen it called like RV data, but here, because they call data like this, they're going to reference data as self.rv data list. The data is a list of dictionaries defined below in the RV class. So data is defined. The attribute of the RecycleView widget that is a list of dictionaries. Right? Could be something else like self.rv data list. Okay. And then data is a list, and each element is a dictionary. I'll just do the proof here. So in line 68, okay, not 68, but here, we're going to inspect this app, and then we're going to do the add. Through the add, we'll import Python debugging tools and set trace. So we'll go Python like this. Elliot DG, enter. Now when I press this enter, okay, let's go like this. It will set trace will be right here. So first let's look at the args. Where are my args, right? This is the self RV object. Now what I want to show you is the RV data, right? So let's find okay, we're already there. We're at the recycle view. So let's do first let's do some inspection, right? There's is there self.name? No name. Is there directory of self? Here, control F, let's look for data. Right? So you see already there's a data attribute to self. So if that's the case, self.data. Let's look at it. And it's correct. This is going to be a list. Let's see if I can move this. The data created looks like this. It's going to be square bracket, curly bracket, left text, left 0, right text, right 0, left text. Okay, looks good. And then now what's the proof I'm trying to show you? It is a list, and each element is a dictionary. So what's the type? Self.data. An observable list. Okay, it's a list. And then let's try type of self.data of the first element. Actually, first let's look at it. What's this? It's this guy. What is this guy? It's going to be a dictionary or a observable dictionary. Let's just click this. Okay, it's a dictionary. Okay, so yeah, and then in this example, okay, I also want to talk about app.get running app.root. So if you're really lost, you want to know where something is, this is going to be entering your app through the root widget. So let's see if app exists, right? Now let's try get running app. It's going to be your RV2app object. Okay, cool. Now let's look at the root widget. It's going to be .root. It's going to be again this box layout. So where are we at? We are right here. We're at the box layout. Okay, let's look at the children, right? Children. You have an RV object and you have a button object, right? Okay, cool. So I want to look at the RV object. Right, so children, I think you can go like 0. RV object, right? But let's look at the button object very quickly. Let's grab the text, right? What is this? It's button object. Okay, let's check the text, right? Add widget to RV list. That's correct. So we'll go back to okay, let's go with this. Back to here. What was I looking for again? Oh yeah, we're looking for data. So this is RV object again. This data will be the same. Looks like this. So I've shown to you that it is a list of dictionaries. Let's see if I'm missing anything. Oh, there. Yeah, you can also go through IDs. So if that's the case, app.get running app this, because if you do like this, it's just going to be a function, right? You have to actually call the function using the parentheses. Okay, to app object. Let's see. What did I call it here? 1 second. IDs. So if that's the case, let's look at the IDs. It doesn't exist. I have to go through root. Okay. Root IDs. So you see here, this is the IDs method. It says RV. Why? Because the ID, we've put the ID here, or Elliot put the ID here. And then you can do this IDs, and then what was I asking for? Data. One second. This RV. Okay, so first RV is going to be the weak proxy to the main RV object. It's not the object itself, it's a proxy, but it's almost the same. Data, and then we got our data. Similarly to through using the children technique, but because your app is going to be with a lot of children, you should just use the IDs method just so that you can specify it. Okay, so you should always use the IDs method, because if you go up here, you got to do root children 0, 1, and then the order might not be always the same, and you got to really specify it. This is just good for inspection, but this children thing is not good in practice. You should always use the IDs to look for a widget. Let's see what's next. Okay, and then it's populated doing init, can be populated at any time, which is the data attribute is populated on init. If you look, you can exit. Then we can look right here. On initialization, the data list is being populated, because let's say we don't populate it, nothing will show up. Right? But if we add widget, we'll have PDB on here. Right, then you can still add it, but we initialize nothing right here. Okay, so here's the list, show the dictionary, show the proof. Okay, now there's some issues with the widget example from Kivy.org. The issue is forcing RecycleView to update, specifically updating in place in a deep level. The example minimally modified does not do that for you. Now the essence of the issue is right here. The def being tracked, because they're asking you to use all these properties, right? But sometimes you're gonna have like a complex widget, complex data. Okay, only the top level of nested object is being tracked. For example, right here, you have a list property 1 and a dictionary high and 0. Changing the top level element will trigger all the callbacks. So if you change the first element here to 4, it will update. Changing a deeper element will be ignored by all the callbacks. So if you change high from 0 to 4, this will not work. Now, it took me a long time to figure this out. Actually, I didn't figure it out. Hamburg Geza figured it out when I was talking to him. But in any case, if you have a RecycleView and then you have a lot of different data, and the data becomes complex, it's you might end up having to modify in place data that's not in the top level. So for example, in the workers paid, right here, I manually call the update right here from parent.parent refresh from data. Why do I manually recall it? It's because I'm going from app root.data. So this root, the root is the RecycleView. I go to the index, and then from the index, I modify the text. Because I modify the text, and it's not top level change, it will not trigger all the callbacks. So that's the crux of the issue with all the examples on Kivy.org, all the official examples. They're slightly simple, and they always tell you to just use a property and modify the top level keys of the list in order to update things. But if you just modify in place on a deeper level that is not tracked, it will not force an update. And if you're not getting forced updates, you should always call RecycleView refresh from data. That's the essence of the issue. KV properties only track the top level. How to force a RecycleView to update? Manually call RecycleView refresh from data. So that's the crux of the issue. And the issue with a lot of the widget examples, because if you go like this, Python, where are you, workers? Actually, let's turn it off. Let's turn it off so you don't see a refresh. So this actually took me a while to figure out, but thanks Arborgesa. So right there, if you check the new RecycleView data, I've actually, let's go like new window. I've actually changed the name. Right? You're a smiley face now, but why is it still showing a sad face? It's because the top level is this, and it's not, this inner level is not being tracked. I'm only very specifically updating this, and I'm not updating the top level. If I had like updated this entire dictionary, it would have triggered an update. But because I only updated this specific portion, which is on a deeper level, it did not trigger an update. So I'm going to do the last one. Should be a smiley face, right? I see a smiley face here in the RV data, and I see the smiley face here, but it didn't trigger an update. So that's just, a caveat that I struggled with. And if I struggle with it, a lot of people will struggle with it too. So I'm just pointing it out there. And then new RV data, just to prove that it's RV data, print RecycleView RV.data. Okay, and then let's exit. Come back here on touchdown. Now that I manually call refresh from data, okay, now they're smiling again when they're, okay. This one is not triggering, very interesting, but most of them are triggering. Okay. So there are other solutions to update data. Solution 0, choose to reset RV data. Does not manually call refresh from data, but this is, so an example is rv.data. Just straight up replace it, right? Very bad if you have large data. It will force an update, however. Don't do it. I'm just letting you know that will force an update. Okay. And then solution 1, choose to update properties. Does not manually call refresh from data. So this is the standard solution. This is Elliot's solution. So here you declare interact data list as a Kivy property. 1 second. I don't think this is correct. It doesn't exist. I think this was for another example. But in any case, the properties I know are here. They're declaring string properties, and then they are just modifying these string properties. Oh, I think this is the... Okay, here's another RecycleView instability refresh, right? Here's a suggestion. Declare the data list as a Kivy property. In Kivy, assign data to this. And then right here, they declare the list property. And in Kivy, declare this. This will force RV data to update when the list is changed. But nobody's saying it's only changed from the top level. Just keep that in mind. When it's changed from the top level, rather than having to update manually, this may address your issue. Doesn't consider posting minimal example. This is just another thing to do. Everyone says to update properties, right? And then they're using Kivy structure itself to force automatic updates because these things in the top level are being tracked. Okay, so we're going here. This is solution 2. This is the solution I use for this my custom example that's based off of the example from Kivy. Choose to update the RecycleView data itself, plus force RV, the RecycleView, to update with RecycleView.refreshFromData. So my solution is to use this RecycleView KVIDsDataViewBehavior. Okay, what does this mean? So if you look right here, I'm not using the standard RecycleDataViewBehavior. I'm using KVIDs. Simply for me, I think it's more natural just to modify the RV data. Right here it says, where are you? RV data. This is an ID, and then this is the text attribute. So if you look, I've given, where are you? I've given every widget an ID, and it's just say ID.text. ID.text. And then if you look here, let's read the text. It says, similar to RecycleView data behavior, except that data keys can signify properties of an object named with an ID in the Kv root rule. Given a Kv rule, label, ID name, ID value, then setting the data list with name.text, value.text would automatically set the corresponding labels. If the key doesn't have a period, the name property of the root widget will be set to the corresponding value. If there's a period, the name property of the widget with the ID listed before the period will be set to the corresponding value. So this is just something to keep in mind because sometimes you have periods in the names. It just says the name property of the widget with the ID listed before the period will be set to the corresponding value. So play around with it. TLDR, don't put periods in your key names, key IDs. So here, this is, for me, this is very cool and very intuitive, I think, because you can just say name.text, you can say value.text in your data and will automatically update. That's something really cool. I don't think I've seen anybody else do it, but I read through the docs and I've seen it, and I thought, where is it? I spent 4 days looking for this because I thought this was default behavior of the RecycleView the entire time. Anyways, most likely you're going to end up referencing your widgets, like every widget by ID. It's just like it's just good practice. And then, in my opinion, it makes it easier to make and handle complex view class widgets. So where is color? Okay, I will just show it off manually. Where are you? So for example, why do I think this is cool? Because if you see right here, and when you apply selection, I'm just going to say employee name label ID. I'll just straight up change the color. I'm not sure what the hex color is. This is RGB. It's 170. But if you look right here, you press it, the color changes. It changes, right? And I think that's really cool because if you wanted to change this using KV, you would have to like specify right here, some sort of like color property, right? And then up here, you would have to specify like color right here, and then do like root dot color. Okay, this is bad naming. Let's say color ID right here, right? And then here it would be like color ID, and then you would select the correct property. I think it would be like numerical property, if I remember the name correctly, right? But if you use, let's delete this. But if you use KVID's RecycleKVIDsDataViewBehavior, if you use that, you could just straight up specify, okay, the widget ID.color, this one. Let's even try another one. Let's try, if it's RGB, then let's try 255 0 0. So this will be mostly red, unless it's BGR, which I'll be Okay, I know what's going on. They're being combined. The colors are being combined. But in any case, pretty cool. You can manipulate the widget without having to prepare everything beforehand. Right, so in my opinion, that's pretty cool. And pretty useful. Okay, so the solution... Ooh, this is kind of hard to read. Why is this so wide? Okay. So the solution, why should you use the original solution, which is using properties? Right. Here, solution 1. Number 1, the structure is flat. Handle everything through view class, widgets, and their properties. Number 2, you have to set everything up correctly, which is, you should always set up your app correctly, right? But what's the con? You have to manually remember to property everything. Everything that you want to change should be a property in order to trigger all of the refreshes. So that's something, it's not really a con, it's like, it's a style, it's just something you have to do. And if you do it correctly, it will make your life a lot easier, right? In my opinion, it's a bit hard to manipulate the view box style view classes easily. I've been trying for 2 days, so this video has been around like 4 days in the making. I'm not sure, but for me anyways, it was more natural to use the KVIDs method than to use the string properties method. And then you still might have to call refresh from data if you modify data in place, especially if you modify data in place in a lower level. Then you're forced to call refresh from data. Why? Because only top level changes are being tracked with these properties. Not everything can be done in KV, so the KV line must be perfectly set up. So for me, the putting string properties is not as intuitive, but if you do through KV IDs, for me it's intuitive. And also, you must have in your mind have already laid out how the app should look like in KV for this method to really be effective. Like if you were to do this straight up, you need to have like a lot of experience, and then it will work out for you. But if you don't have a lot of experience, then it might not be as intuitive, especially when you're making like more complex apps. It will not be as obvious. And then, because not everything can be done in KV, you're going to end up doing it in Python anyways. So, like I said here, this method is the best, but it's also easier if you're an expert. If you're not an expert, it's fine to do things manually. It's fine to do things strangely. Simply because there's like not a lot of style guides out there, and not a lot of people to talk to about this, and not a lot of resources, which is why, Kivy School exists. So, what I mean by flat structure of solution 1, all you have to do is handle the view class widget and properties. So for solution 1, which is just updating properties, you need to handle your KV, declare everything as a property correctly, and then structure the app to be easy to make with KV. It's not always possible, it's not immediately obvious, like with complex apps. So keep in mind with that. And then you might have to manually force updates anyways, especially if you're updating things in a deeper level, because they only track top levels. So the structure of the app, if you were to do this solution 1 solution, it'd be like this. This is your Kivy app, right? This is your RecycleView. You initially update on init your data, right? Your data is picked up on init with the widget. Where are you? So RV data, you're picked up by this view class widget, which is 2 buttons, right? Picked up by 2 buttons, and then all these this view class widget, this view class widget right here will handle all the updates. Why? Because you're using properties, using string properties, list properties. Any property from Kivy properties will force updates because you're modifying top level data. And then this simple view class widget will define instances, and then because you're manipulating properties, it will force updates, right? So if you have user input, it will be handled by the view class widget. So if you go to like class 2 buttons will be defined here. It'll be handled, well, there's not really anything going on because it's a simple app, but it will be handled with this view class widget. And then you as a dev, what you're supposed to do, you implement behavior through KV and properties. Very simple. If someone had taught you about this, if you knew it was like if you watch this video, now you would know, okay, this is the correct way to do it, right? This is the not super correct way, but still a solution. So solution 2, which is the Kivy school, from me, this is my opinion. Okay, I don't represent everyone. This is my opinion. Now you should use KVIDs. Where are you? You should use RecycleKVIDsDataViewBehavior simply because, number 1, you can use and manipulate complex widgets by referencing with ID in your RV data. I think for me that's pretty cool because I even thought it was default behavior, right? It's not. You gotta use KVIDs. All you have to do is set IDs. You're going to set IDs anyways. If you're going to reference these widgets, most likely you're going to set IDs anyways. You can modify KV at any time. That's pretty cool to me, especially having that power to modify, because if you're going to modify with properties, right? Again, you would have to set up the property and then you have to manipulate the properties correctly. So, oh, here's the color example. We already ran the color example. Basically, you can say this is the ID of the widget dot color, and then it will change it. And then here's the trade-off. You trade in property structure for ID structure, which you already need for widget drilling. And widget drilling is basically calling app.getRunning.app.root IDs, you know, the correct IDs. Most likely you have IDs anyways. So this is not too far off from what you're already doing. Now I will tell you the cons to the solution. You must manually update RecycleView with refresh from data. The easiest way is on touchdown. On touch-up looks laggy. This is because you're going to have oh, what's going on here? Okay, this is because you're going to have like just a complex dictionary. You're gonna have a complex dictionary like this, and then if you change like a data in place, you will not trigger any refreshes. So you will be forced to call refresh from data. And then I'll show you touch up and touch down. So look right here. On touch down, right? Refresh from data looks like this. Now let's, okay, first let's do touch down. Touch down, fast update, right? Fast update. But if you do touch up, it will actually look like it's lagging. This tricked me because I was like, oh man, I gotta fix the lag. Actually, it's not that. It's because I'm touching down, it's not updating. When I touch up, it updates. Touch down, touch up, right? So you really need to know the correct event. Which is, you know, this is like a dev error, I admit that. But this is just to say, look at this. It looks laggy, it's not laggy. It's just because you're using, or I was using the touch up event. It's not touch up, you should use touch down to make it fast. So again, here's touch down. Like this, fast updates. Use the correct event. It's more complicated to update KV after initialization. You can't reference RecycleView data because it's not instantiated yet. So this is just, you can't like say root.get data. You have to set it up correctly. It's a little bit more complicated. Oh, here's another one. Calling refresh from data from view class causes infinite refreshes. So where are you? There's 2 refresh from data that will really bug you out. Okay, I think it's just this one. So look at this. If you manually call refresh from data, it will infinitely bug out like this. Why? Because, okay, I gotta kill this before it destroys my machine. applying selection, when you add these widgets, apply selection is going to be called, and then because it's called, it will trigger a refresh from data, and because you refresh from data, you get more widgets, and the new widgets are going to check for apply selection, which then forces a refresh. Just keep in mind, infinite loop like that might happen with these manual refreshes. Let's see, I've done this and done this. How to manually call refresh from data. Again, parent.parent. It's just RecycleView right here. I think I can even PDB. I think that's an appropriate time. So again, on touch down, let's check it out. Touch down. So what's the args? Right? All of this, let's see, self is the box layout. That's correct. This is the touch. Okay. A huge amount of data for the touch. Basically, it just says where you are, what you're doing, the motion, I think. Okay, what next? So self, who is self? Box layout. Now, what's your parent? Now, because I have a complex widget, actually, if I'm selecting left, so I'm here with the emojis. Now the parent is going to be the box layout, selectable box layout, right? Oh, okay, no, that's self. The parent is going to be selectable box right here. Recycle box layout. So we are here. This is the parent, right? Check parent again. Parent. Now you're at the recycle view. So this is the self, selectable box layout. This is the parent, recycle box layout. This is the parent recycle view. Then from recycle view, directory of recycle view, you can see refresh from data method. So that's why there's two parents, because self is selectable box layout right here, here, and here. Then the parent is going to be selectable recycle box layout. Then the parent is going to be recycle view, and recycle view is the one that's refresh from data. So let's type exit and turn off PDB. Okay, so with this method, you have to keep track of two things: recycle view data and forcing updates. And then my expectation is that manipulating data forces an update. It's not always the case with updating data in place, especially in a deeper level, which you will end up doing with the key IDs, KV IDs, like this. So recycle view refresh from data may be required. Now here's the structure of solution 2. The dev must handle recycle view data and manual refreshes. So again, you have a recycle view. You update on init. This is the data. The data is picked up on init to the view class widget. So the view class widget is selectable box layout, which is this. This widget determines the format of the instances, right? User input, the user will interact with the view class widget and their instances. And then you as a dev, you must correctly manipulate RV data to update these widgets. You must also call manual updates. And then while the user is interacting with this view class widget, you will get inputs that you must handle. And you must handle this correctly in the RV data, and you must handle these inputs correctly in the view class widget. You're also doing the updates here, but because the user input is handled by the view class widget, and these properties are always automatically updating, it's a bit simpler with more with a more thought out setup. Let's see what else. So why two parents? I said this already. Let's see, PDB. Okay, and that's it. All right, so that was a long one. Thank you for watching. Like, comment, and subscribe.